Now from this question, we are expected to determine the frequency of the free vibration when a body of mass 20 kg is suspended from a spring which deflects 15 mm under the weight of the body. We are also expected to find the viscous damping force required to make the motion aperiodic at the speed of 1 meter per second. Now, if damped to this extent, a distinguished force having a maximum value of 187.5 Newton and vibrating at 8 Hz is made to act on the body. We are expected to find the amplitude of the ultimate motion. So we have three things we are expected to find here. So the first one, we are expected to find the frequency of free vibration. So the frequency of free vibration F subscript n is given by 1/2 pi square root of g over deflection, and that is, we already know g, acceleration due to gravity 9.81 over deflection. These are deflection. Deflection is, we are told from the question, it deflects by 15 mm, so we convert to meters. That's 0.015. That's why I have this. So eventually, this is the frequency of free vibration. So the next, we are expected to calculate the viscous damping force. Okay. Now the viscous damping force is given by C, which is damping coefficient, multiplied by velocity. Okay. Of course, you remember in equation of motion, we have m d square x over dt squared plus c dx dt and then plus kx, all equals 0. Okay, so dx dt here is your velocity and then c is the damping coefficient. So this kx is your stiffness and then x is your displacement. Okay, so now the same thing here. This is your velocity v and then c is your damping coefficient. So that's cv or c dx dt. Okay, so now your damping force is given by cv, that is damping coefficient multiplied by velocity. So to make the motion aperiodic, it means the damped frequency is going to be 0. Okay, or the motion becomes critically damped. Now for motion to be critically damped, it means the damping factor is going to be 1. Okay, and once the damping factor is 1, we already know the formula for finding the damping coefficient as C equals 2m omega n multiplied by the damping factor. So since the damping factor is 1, it means we are left with C is equals to 2 multiplied by 20. 20 is the mass, multiplied by omega n. So we need to know, calculate our omega n. So omega n is given by square root of s over m, where s is the stiffness. So stiffness is given by weight over deflection, and then weight is given by mg. So mg over deflection. So that means 20 multiplied by 9.81 over deflection, which is 0.01. And eventually omega n is 130.80 Newton per meter. I mean, stiffness is 130.80 Newton per meter. So now that we know stiffness, we put it into this formula. So it means omega n is now going to be 1 square root of 130.80 over 20, and that gives 25.57 rads per second. Okay, so now with this, we can find our C conveniently. Okay, so that means our C now becomes 2 multiplied by mass, which is 20, multiplied by omega n, which is 25.57, and then your C gives us 1022.8 Newton per meter per second. So now that we've known C, and we know that force is given by C multiplied by velocity, we have also been given velocity from the question as 1 meter per second. So multiplying C by V, V is 1, C is this, we are now going to have 1022.8 Newton. It means the force we are looking for is 1022.8 Newton. That is it. We are expected to find the damping force required to make the motion aperiodic at the speed of 1 meter per second. So now the next question is we're expected to find the amplitude of the ultimate motion. So now, of course, when talking about the amplitude of the ultimate motion, we are talking about the maximum displacement of the first vibration, and it's given by x max. So we're already used to this formula, which is given by F over square root of S minus M omega squared, everything squared, plus C squared omega squared. So now we have to recall that F, which is the frequency, is given by omega over 2 pi. But from the question, we have been given frequency. We have been given frequency as 8 hertz. Okay? So that means we can get our omega. And our omega here is now going to be 2 pi multiplied by 8. That's 16 pi. And then that's 50.3 rads per second. Okay? So now that we know our omega, we know our omega here. We also know C here. Okay? We know omega, we know the mass, and then we also know the stiffness. Okay? We already calculated the stiffness from here. From here, this is the stiffness. That's 130 80 Newton per meter. We know the mass. The mass is 20. Okay, so just since we know all these values now, we'll put it into this formula. So now force has also been given from the question as 187.5 Newton. So put that, then bracket S minus 20 multiplied by 50.3 squared, which we just got. That's our omega, everything squared, plus C squared, bracket again 50.3 squared. So by the time you simplify this, you get this. By the time you simplify this, you get this. Then square root of the summation of this, you get this. So this divided by this, you get this. That's 2.94 exponential minus 3 meters. So converting to millimeter, you have this. So this is the amplitude of ultimate motion.